Okay, we are recording. Sorry, Zach, for the slowness. All right, so we are trying to find the Taylor series for the square root of x centered at 1. You had a problem on this in homework? So if we write this as x to the 1/2, it's going to be easier. So the first derivative then is going to be 1/2 times x to the negative 1/2. Second derivative. Well, that's going to be bring down the power again. So what is that? Negative 1/4 times x to the negative 3/2. Third derivative. Negative times a negative is a positive. 1/4 times 3/2. Yeah, that'd be 3/8, correct? X to the negative 5/2. So this is really 3/8. X to the negative 5/2. Okay, let's do another one. Running out of room, new page. Fourth derivative. It's going to be 1/4 times 3/2 times negative 5/2 times, that's going to be x to the negative 7/2. And that cleans up a little bit, doesn't it? Yeah, negative 15/16 x to the negative 7/2. All right, just for the hell of it, do one more. This is good practice. Now, let's see, where did that 1/4 come from? Ah, thank you. So I have 1/2 times 1/2 times 3/2 times 5/2. Yeah, we get some negatives in here. Now we're going to have times the 7/2. Ah, I know. Okay, so let's see. This one is negative, so this one is negative. Now, times x to the negative 9/2. And we could clean that up quite a bit. So 105, is that right? 35 times 3, yeah. Over 32. X to the negative 9/2. Yeah, you're going to do a whole lot of derivatives in the homework for section 10, 8, and 10, 9. Yeah. Okay. Then we need to plug in our center. What's our center here? 1. Okay, so I'm going to start making a table on the next page. You guys are going to help me out and make it. I chose the center to be 1 here. Yeah, if I chose the center to be 0 here, would that be a problem? If I plug in 0 to each of these derivatives, what do I get? No, I don't. I get undefined, yeah, because the negative exponent means flip it, so I get 1 over 0. So I cannot do this series at 0 because most of the terms are undefined. Yeah, right, because this is really 1 over twice the square root of x, so x cannot be 0. Okay, so right after the first derivative, I realized, oh, x can't be 0, better not use it. Why can't x be 0? What is it about the graph of this thing that means x can't be 0? Like, because here x can be 0 in the original function. What is special about this particular curve that we don't have a derivative at 0? Well, this curve has the point 0, 0 on it. Why isn't there a derivative there? This is reaching way back to Calc 1. The tangent is vertical there. Yeah. If you watch the tangent lines as you move the point of tangency toward the origin, you'll see the tangent goes vertical. Vertical slope is undefined. That's where that comes in. Okay. Anyway, that was just a little trivia. Let's make our table. So in our table, we need to keep track of what n is doing. We have a whole bunch of derivatives going on. Okay, so help me summarize the derivatives. The first one is x to the 1/2. Then I have what? 1/2 x to the negative 1/2. Then we get negative 1/4, is that right? X to the negative 3/2. Then we get positive 3/8. Shit. My pen just freaked out. Please stay for just a little while longer, pen. Okay, let's try that again. Oh, I got to reset the board. Hang on. Okay, let's see, where did we leave over? That was supposed to be an 8 down here. X to the negative 3/5. Then we had, was it negative 15/16? What's that? 5/2. Oh gosh, where did I get 3/5 from? That was weird. 5/2, right? All right, x to the negative 7/2 here. And we did what, one more? So that'd be positive 105 over 32. 9/2, right? Okay. So then we plug. So this, what we calculated here is f nth derivative of x. Now we need to plug our center into that. Okay. 1, 1/2. Negative 1/4, 3/8. Negative 15/16. 105 over 32. Next step. I plugged in 1 for x. What's the next step? Yeah, n factorial. We divide each of these by n factorial. So we take the results we got from the nth derivative with the center plugged in, divide by n factorial. All right, so 0 factorial is 1, so we have 1. 1 factorial is 1, so we still have 1/2. 2 factorial, so this is negative 1/4 times 1 over 2 factorial, which is 1/2, which gives me negative 1/8, right? Next, we're going to use 3 factorial, so I'm going to have 3/8 times 1 over 3 factorial, which is 1/6, and so that's going to give me 1/16. Ooh, interesting, 1/16. Here, I've got, what, negative 15/16. What factorial do I want here? So that's 4 times 3 times 2, and a little bit of cancellation happens. Let's see, the 3 goes into there, leaving a 5 behind. So it looks like we get negative 5 over 128. Is that right? 16 times 2 is 32, 64, 128, yeah. I'm only good at some arithmetic, not all. What? It's not, no, it's, I'm not nearly as smart as some people give me credit for. Ask my wife. 5, 4, 3, 2. Okay, so let's see. 3 goes into that, and 5 goes into that, and I think that leaves 7 behind in the numerator. What's 105 divided by 5, then divided by 3? Should be 7. Positive 7 over, let's see, 32, 64, 128, 256. Thank you. Wow, this is a lot of work. Now, why did I go this far? Well, the reason I went this far was I always like to try and find a formula for the pattern. And sometimes those formulas are very elusive. Sometimes they're impossible to find. And the only way to get the next term is to continue this process another line. Okay? You could challenge yourself later to try and find a closed formula for this, and I kind of gave a hint on how to find it, which was when I wrote all that shit out there. Okay, so I'm going to leave that for Jeff for homework, because he needs to write more stuff down. All right, we're ready to write our series. So based on these coefficients, write down what you think the series, how the series for square root of n, square root of x starts. Yeah, so according to these coefficients, what does the series of this function look like? Square root of x equals blah, blah, blah. Write down your best guess. Good job. Thank you, Anna. He totally needed that. Is this relevant to calculus? No. Okay, then please hold on to it. Did you write the series down?
Of course I did.
Where?
Right there.
Right, please. Less talking, more writing. Right. More writing, less talking. Oh, sorry, Jeff distracted me, so I didn't get to see what you were writing. Oh, you're trying to write the formula. No, I did not want you to write the formula. I just want you to list the terms.
Oh, I was trying to write the summation.
No, you can, but do that later. It takes a while to figure out.
Oh, that's what you want
No,
us to do.
list the terms. No, Jeff can go home and try and find a closed formula. We are just going to write down the terms. What are the first several terms of this power series? Write that down. 1 plus what? Yes. That's okay. No, don't erase it. You better not erase anything. Do not erase it. You have some wonderful work there.
You don't know that I'm wrong. I'm pretty sure half of it's right.
So here's what we've discovered, I think. Square root of x equals 1 plus 1/2 x. What's next? Minus 1/8 x squared. Oh, this is totally wrong. Why is that totally wrong? It was the third one is negative 1/8 for sure. But something I wrote down is horribly wrong. How many people started like I did? The 1 is completely right. The 1/2 is completely correct, and so is the negative 1/8. What is wrong though? If I try to graph this, it will not look anything like the square root of x. Well, kind of will, but not really. It can't start at 0. What can't start at 0? The series can't be centered at 0. Where did we center it? Oh, I'm writing a series centered at 0. No, where does the series have to be centered? So what should my powers be of? Not x, but x. No.
Should they be on?
Powers of x minus 1. It's got to be x minus the center. X minus the center squared. You will make this mistake in the homework. I guarantee it. I make it all the time. I'm so used to series centered at 0, I forget that we center them elsewhere sometimes. If it was centered at 3, it would be x minus 3 in powers. Yes, correct. All right. Plus 1/16. Yeah. 5 1/28.
Alrighty.
7 256, is that right?
I stopped.
Okay. This continues, correct? Okay. So what's the interval of convergence?
Oh, well, it is. Is it? I feel like it is. -1 is less than or equal. You have to check the end points, but is it -1 less than or equal to x?
How do we, first we have to find a radius of convergence. Okay, so we can't do this yet. What about the radius? Oh shit, I counted wrong.
Okay, I got confused. I was like, oh, no.
Those are 4 and 5. Thank you, 4, 5. Radius of convergence, maybe. Let's see, how do we find radius of convergence before? We used either the ratio test. Okay, but to use a ratio test, we need a formula for the terms, and we don't have one yet. Oh, okay. So I'm going to leave that as a homework assignment. Do you have to do it? No. Sometimes it's fruitless trying to find them. You won't. Sometimes you will, though, if you try hard enough. I've worked really hard at these all my life, and I have found a fraction of the ones I've set out to. Formulas for them. But I can keep taking derivatives and find the next term, even if I can't find a pattern that's a formula. Okay? When you're exhausted, sick of it, you've had enough. Okay? So, I'm going to leave this for now. I will work on a formula too. I know I've done this one before, but I don't have it written down in my notes. There's a famous mathematician that did that. He said, this is a lovely little theorem, the proof of which is a little too big to fit in the margin of my book. Just believe me. And it took people, like 250 years to finally solve it? With math that didn't exist when this guy said he proved it. Okay. Anyway, try this. Try to find a formula for homework.
All right.
He was right.
No, we're going to do something else right now.
But he was right.
He was right. Yes, what he said was true, but it's very unlikely he actually had a proof for it because lots of new math had to be created to solve his problem. It's a problem called Fermat's last theorem. Okay, so let's do another problem. How about, let's see if I can find something cute in the book. Ooh, that's a cute one. Oh, I know what we're going to do. We're going to do the hyperbolic cosine or sine. Okay. E to the x minus e to the negative x over 2 is what's referred to as the hyperbolic sine function. We're going to attempt to find its power series. To do that, I need to know the power series for e to the x. Anybody remember what that was? Power series for e to the x? Ah, yes, 3 factorial. All right, we are on a roll. Okay. Now let's write down a formula for e to the negative x. So that means we have to replace x with a negative x. Well, 1. If I replace x with a negative x, what's the next term? Negative x minus x. If we square negative x, what do we get? Positive x squared? That's not too bad. That's not too bad. Okay, So I need these two to create the hyperbolic sign. So what am I going to do next with these guys?
Cancel stuff out.
I'm going to subtract, right? So I need to subtract this whole series here from the one above. All right, let's see. 1 minus 1 is 0. It's a good start.
Oh, I see what we're doing now. Oh, yeah, okay.
Right, so I'm subtracting these guys. So 1 minus 1 is 0. This says x minus negative x. That's plus 2x. Okay. And then I'm going to take x squared over 2 minus x squared over 2. That's 0. Then I have minus 2 of these. Oh, cute. Oh, shit, it's a plus. Yeah, plus, thank you. These guys are 0. Let's write the next one just for fun. What do you think the next one's going to be?
Plus 2, blah, blah, blah.
X to the 5th over 5 factorial. Okay, we got a pattern going on here. Okay, so we wrote this down. We wrote that down. We did the subtraction. What's next?
Divide by 2.
Divide by 2. Okay. So then we divide by 2. And that implies we get x plus x cubed over 3 factorial plus x to the 5th over 5 factorial plus, that looks kind of familiar. Holy jinkies, Batman. What does that look like? It looks like the ordinary sign, but what's the difference? Yeah, this regular sign alternates. The hyperbolic sign is the same coefficients, but doesn't alternate. Isn't that mind-blowing? How could it that the sine of x is related to e to the x? Oh, wait a minute. Check this out. This is getting more mind-blowing for me. I don't think we talked about this before. The sine, or the hyperbolic sign, are basically these odd terms. And the cosine are the, oops, wrong color, I wanted a highlighter. The cosine are the even terms. So somehow, sine and cosine add up to be e to the x.
What?
Oh my gosh, how can this possibly be? Let's try that.
I don't understand how it all connects. You always put 3 in one box and then all in another box.
Now we're merging boxes. Okay, what is the series for the cosine of x?
That's how I came up with E.
Maybe.
Maybe.
Cosine is 1 minus 1/2 x squared plus, let's see, what's next? 4 factorial, I'm just going to call it x to the 4th minus 2, 4, 6 factorial x to the 6th, yada, yada, yada. Yada. Okay. Sine, let's write it down. Sine of x is equal to what? It starts with x, and then minus 1/3 x cubed. No, 1 over 3 factorial, sorry. What's next? Plus 1 over 5 factorial. X to the 5th. Minus 1 over 7 factorial, x to the 7th plus blah, blah, blah. All right, so now we're going to try and add these two and see what happens. Plus, all right, plus, okay, so this is going to give me 1 plus x, right? Minus 1/2 x squared minus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th plus 1 over 5 factorial x to the 5th minus, okay, let's pause there. We got a lot of terms. Is that black thing e to the x? There's some sign issues. It goes plus, plus, minus, minus, plus, plus, minus, minus, plus, plus, minus, minus forever. Oh, we are so darn close. No.
It was really cool. And then does it like?
Can you think of, like, what have we taken powers of before that alternate sign in pairs? And 2n. Yeah. Oh wait, I got an idea. I have an idea. I is my idea. Let's think about I for a minute. Powers of I. I to the 0, I to the 1, I squared, I cubed, I to the 4th, I to the 5th. Okay, what's I to the 0 power? 1. What's I to the 1st? I. What's I squared? -1. I is the only number you can square and get -1. That's one definition of I. You can either consider I to be the square root of -1, but if you square both sides of it, that implies that -1 is I squared. That's I. It's supposed to be an I here, sorry. I is the square root of -1. That's supposed to be an I right there. If you square both sides of that, you get -1 is I squared. You with me? 4th grade.
I can't remember that.
Okay. What's I cubed then?
Oh, it's like
Well, it's I squared times I.
yeah, so it's -1.
-I. What's I to the 4th? That would be like I squared times I squared, which is 1. What's I to the 5th?
I can't remember. Is it -1?
It is I. Because it's I to the 4th times I, right? I have a pattern that repeats the same thing over and over again. 1I, -1, -I. 1I, -1, -I.
Should we memorize this thing?
Check it out. Positive, positive, negative, negative. Positive, positive, negative, negative.
Oh!
What is our black sequence doing?
That. Positive, negative.
Okay.
So just maybe it's really I.
Turns out that e to the power ix, if you plug ix into the formula, that means you would have 1 plus ix plus ix squared over 2 plus ix cubed over 3 factorial and so on, will break down and you can reorganize it and you discover that you get cosine series plus I times sines series. But wait, it gets better. Yeah, I'm going to skip the steps in between. You can try it later. It's pretty cute. It's in the book. But if I let x equal pi, this is pretty cool. Check this out. Then I get e to the I pi on one side. Now that's pretty cool to see those three numbers together, e, I, and pi.
That's pretty intense.
On the other side, I get the cosine of pi. Anybody remember the cosine of pi? Cosine of pi is -1. That's correct. And the sine of pi? 0. So that other part goes away. So I get this right here. If I bring the -1 to the other side, I get e to the I pi plus 1 equals 0. 5 of the most famous numbers in existence are all related in this cute little formula. Holy shit. The hair on the back of my neck is standing up right now.
Can you show this to me?
I may have. I kind of teach this in trigonometry. I don't think you guys took trig from me, though.
That's pretty cool.
Oh, maybe we're playing out there? Maybe. Yeah.
That's pretty cool.
I remember
That's pretty
seeing
Like,
super.
I don't have a tattoo yet, but if I were to get one, this might be it. I said that about e to the x. I thought it'd be kind of cool to have e to the x's series revolving around my arm. You know, like some people get those weird bands. Okay, I got a surprise for you guys now. A quiz. Yes. You are totally ready for this. This is a quiz on section 10.7, the first stuff we started. Sure you are. All you have to do is find the radius and interval of convergence here for me. You can use a calculator, but you do not need your notes. If you really want to use your notes, then I'll give you a 10-minute time limit. Otherwise, you can take as long as you need. There's one problem here. I need the radius and interval of convergence. And we can pick up this problem next time. Oh shit. Make your best guess. You've observed a lot of this. You're clever.